Hello everyone, and welcome back to another GIS Mathematics lecture video. And in this video, I want to talk about lines and continue our discussion on the slope-intercept equation of a line by talking about what do we do when we don't actually have the equation, and instead we're given pieces of information that are related to the line. And I think it's easiest to start this discussion by talking about what if we were given 2 points that we say are on the line. And for those of you that maybe don't know this fact, right, you can define any line with 2 points, assuming that they are indeed on the line that you're talking about. And in this case, we're just going to say that they are. And so we have 2 points. We have the point 3, 3, which is this point right here. And we have the point 5, 4, which is this point right here. And we're trying to find the equation of the line that passes between them. And I've sort of, in dashed green, maybe you can't see that, in dashed green, I've sort of highlighted the line segment that we're talking about here. And so let's just sort of recap. When we're talking about the equation here, right, when we're talking about equation, right, what are we talking about? We're talking about this equation, the slope-intercept, y equals mx plus b. Right, y equals mx plus b. This is the equation that we're trying to fill out here. And you'll notice here that we need a slope, and we need an intercept. Well, unfortunately, we don't have either of those, right? Instead, we just have a couple of points. Now, I prefer to start off by talking about the slope here because it's the easiest, in my opinion, of the two to find. So if we have a slope, right, we have m, which we said is the slope, right? We've also said, sort of using generic English, that slope is the change in y due to a change in x. Right? We sort of defined it as what happens to y when we change x. And we've also used English in saying that we sometimes refer to slope as rise over run. Right? We've thrown this out as well. Well, what does rise mean? Right? Rise means that how much does the line rise? Right? How much does the line go up or go down, for that matter, as we go along it? And so you can think of rise here in terms of the things that we might have as being the same as, well, how does the y value change, right? When the line goes up or goes down, right, that's equivalent to a change in the y. So what we can do here is, given 2 points, we can say that this rise here is the same as something we've seen in previous examples of y2 minus y1. We saw this when we were calculating distances, with y2 being the y value of one point and y1 being the y value of another. So you can see where this is going, hopefully, in that run is the same as saying, well, okay, how does the line change in the x direction as we go along it, right? How is it running as we go along? And so you can see sort of similarly that this would be equal to the change in x. So x2 minus x1. So hopefully you can see how we went from m, we defined that as the slope, we've talked about what slope means conceptually, and now we've got a sort of mathematical framework here using the information that we currently have. So let's just really quickly run through what this would look like. So let's do this. Let's set up our skeleton equation. So we have a division and we have a subtraction on the top and bottom. So let's go ahead and fill in our x2 and our y2. Well, y2 is going to come from this second point here, and our y is always the second number, right? In ordered pairs are x, y. So our y2 is going to be 4, and our x2 is going to be 5. Right? So then our x1 and y1 are going to be from the first point. And in this case, right, x1 and y1 are both 3. So we're going to put a 3 there and a 3 there. Now, if we sort of complete the math here, right, 4 minus 3 is 1, 5 minus 3 is 2. So our slope here is going to be 1/2. So let's just quickly look at this line, this little dashed line segment that I made here. And I always think it's best to sort of just double check visually if this makes sense, if you can. Right, in this case, we can pretty easily verify that if we go over 1 in the x, so we're changing x by 1, right, we're going from 3 to 4, what happens to the y? Well, the y goes from 3 to roughly 3.5, which is a change of 1/2. So again, our slope seems to make sense here. So let's go ahead and try and figure out our intercept. And to do that, in order to solve for this intercept here, we have to think about what we have and what we need, and if there's a way that we can sort of rearrange everything to solve that problem. And hopefully this isn't too advanced, but you can think of this slope-intercept equation, right, as being an equation. And as with any other equation in math, you can always rearrange them, right? You can solve for different components, assuming that you keep the signs and things appropriate. So let's go ahead and let's rearrange this y equals mx plus b equation to solve for b. So if we do y equals mx plus b, right? So the first thing I would do is I would move b to the other side. So that would be y minus b equals mx. Then I would move the y to the other side. So that's negative b. Again, this is what I meant when you said you have to keep your signs consistent, right? When we subtract a y, we keep the negative with the b. So that's negative b equals mx minus y. Now, personally, I don't like to have a negative over here because that's going to make an extra step for us later. So we're going to distribute the negative by multiplying both sides by -1. So if we multiply -1 times negative b, we get b. And if we multiply -1 by mx minus y, we get negative mx. Right, that's distributing the -1 to this. And then -1 times negative y is going to be positive y, so you get a plus y there. So now we've converted this to b equals negative mx plus y. And you might be saying, okay, well, how does this help us? Well, you have to realize we actually have all three of these components, right? We just solved for m up here, so we have slope. And we have two different options for x and y, right? We can use either one of these points because these points are an x and a y. You know, this equation is talking about them in generic terms, but these are a value for x and a value for y. And this equation will hold true for any x and y, you know, assuming they're on the same line, and we've already said that these are. So let's go ahead and throw in one of these points, and I'm going to use the point 5, 4. So we can use these points. We can say b equals negative. Our slope is 1/2, right? Coming from here. So our slope is 1/2. Our x, we said we're going to use this point, so our x is 5. Plus our y is coming from this point, so our y is going to be 4. So negative 1/2 times 5 plus 4. Okay? So let's walk through the arithmetic. Negative 1/2 times 5 is going to be equal to negative 2.5, and that's just because we're dividing 5 by 2 and then carrying over the negative, plus 4. So if we have negative 2.5 plus 4, that's the same as saying 4 minus 2.5, which is the same as saying 2 minus 0.5, which is going to be equal to 1.5. Right, so our b value here is going to be equal to 1.5. And let's just quickly see if that makes sense. So if we extend our line out at the slope of 1/2, so going down 1 over 2, and continuing sort of through there, right, you'll see that we hit it at exactly the point x equals 0, because that's what the y-intercept is. X equals 0, y equals 1.5. So to sort of circle back, what is the equation? Well, we need to rewrite this using the information we have. So we will say y equals 1/2 x plus 1.5. All right, y equals 1/2 x plus 1.5. Hopefully that made sense. Hopefully you're able to follow all the parts. If anything seemed confusing, I encourage you to go back through, rewatch the parts you're confused about, and as always, please reach out. Thank you.